Hey guys, in this episode we will add basic movement to our player. We will take a look at variables, if statements and player input. Now before I continue, if you haven't already, then subscribe to my channel and click the bell button to get notified every time I upload a new video. That way you can follow along with this series and stay up to date with my latest video.
Before we get started with player movement, let's change the camera view to 2D mode. Well, to do this is really simple. We just need to switch from 3D view to 2D view. You can do this by clicking the 2D button in the top left corner of the scene view. Now we can select the main camera and click the drop down button, switch from perspective to orthographic. Now let's move the camera a bit upward that we can only see the beginning of the ground. And we are ready to get coding. In the previous episode, we simply added the sideways force to our player. Right now, our issue with this is that our player doesn't stay on the ground. Now one way to fix this is by selecting the player under the rigid body constraints. We could, for example, freeze the rotation of our player either on the X, Y or Z rotation. In this instance, we want to freeze the Z rotation. And if we hit play, we can see that it slides smoothly. But keep in mind, when you're creating a 3D game and you want your cube to rotate in different directions, then there is another handy thing we could do. So let's uncheck that, and under the project panel, the reason for the cube jumping around is because by default there is friction between the cube and the ground. And by using a physics material, we can choose how many friction we want. So let's go in our project panel and create a new physics material. We can rename this to slippery and change the dynamic and the static friction to 0. Then we can drag it onto our ground. So if we select the ground and open the box collider, then we can see the slippery material is applied. That means that if we hit play now, there is no friction between our player and the ground and he's just going to slide off. Now we can select the player and double click on the player movement. In this line we add a force of 2000 and of course multiply it by time.delta time. However, it would be really helpful if we can modify this value in the inspector, and we can do this by adding a variable. Practically, a variable is a container. You can create new ones at will, fill them with stuff, move them around and reference them as needed. They can even be empty and still be useful. For starters, you should learn and memorize the 4 fundamental data types. Integer, we just write int, and this can only store whole numbers. We also have a float, and this stores a value with decimals. We also have a string, and this stores a text, and the simplest of them all is a boolean. We just write bool, and this can only have 2 values, true or false. So if we create a variable, it looks like this: int speed, and Unity allows us to edit a variable in the inspector. By doing this, we mark it as public. Currently, this value is unassigned. We can assign a value by typing equals and then the value of 2000. And to get the value, we simply write its name. For example, we can do debug.log and in the parentheses, we type in speed to display it in the console. We could also edit the value of a variable. Here we set the speed equal to 500. We can also increase the speed value by 100. To do that, we just write speed equals speed plus 100. And this will display a speed of 600 in the console. So if we want to turn this 2000 into a variable we can edit in the inspector, we just need to create some space under the rigid body and write public float sideways force, and we equal that to 2000. But remember, when you're using a float, we always need to add a f after the value. And by using a float, we can fine tune it with decimal places. So we can just replace the 2000 with sideways force. If we now hit save and head back into Unity, we can see a new line in the inspector of sideways force. And here we can edit the value. We can set it to 5000, hit play, and it will just fly off. And now it's time to look at some player input. So let's head over to Visual Studio. Create some space in the fixed update and write if and open and close parentheses, and then after the parentheses we open and close with curly brackets and hit enter. This is the basic structure of an if statement. This allows us to only execute code if a certain condition is met. Between the curly brackets is where you put your code, and inside the parentheses is where you put your condition. So for example, we can write if 5 is bigger than 4, and only if the condition is met, it will run the code inside the curly brackets. So you can do this with numbers and many more. But for this instance, we want to get player input. So we just write input.getKey and open and close parentheses. Now inside the parentheses, we can add quotation marks, and inside the quotation marks, we write the key that we want. But a better way to get a specific key is to replace the quotation marks with key code dot and then the key that you want. In this instance, we want to look for D. So hit D and press tab to select it. So inside the curly brackets, you can add the code that you want. But for now, let's cut and paste this in the if statement's curly brackets. Hit save and head back into Unity. Press play, we can see that the player only moves when we hit the D key. But we also want to go left. So head back into Visual Studio. We can copy and paste this entire if statement. Paste it under there, and instead of the D key, we want to check if the A key is pressed. So hit A and press tab to select it. Now, we can use the same force, but in the opposite direction. And to do that, we simply add a minus before the sideways force. Hit save, head back into Unity, and press play. And now, if we hit D, we can see that the force is being applied. And also if we hit A, we can see that the sideways force is added in the left direction. So now, our player moves left and right, but we also want our player to jump. So let's stop play mode and head into Unity. Now getting player input in the fixed update might sometimes be a little buggy. So if we check for jumping or crouching, we can do so in the update function. So let's create a new update method. We can just write update, hit tab, and it will automatically create the update method. And inside the curly brackets we write if input.getKeyDown. The reason we use getKeyDown is because we only want to check if the key is pressed once. Open and close parentheses, and inside we write keycode.space. And inside the curly brackets we can write playerRB.addForce, and now we only want to add the force on the y-axis. By doing so, we'll write 0 on the x, 10,000 on the y, and 0 on the z. And remember to multiply this number by time.delta time, and close that off with a semicolon. Now, we also want to adjust the jump force in the inspector. So under sideways force, let's create a new public float. Call this jump force, and set that equal to 10,000 f, and close it off with a semicolon. Now, if we hit save, head back into Unity and press play, we can see that we can move left, right, and jump. And now, it already starts to feel like a game. I know, player movement is not the easiest to do in Unity. So if you followed along with this tutorial, really good job. But if you're struggling with some code, just let me know. I'll have links of all my profiles and information that you can get in contact with me, and I will surely help you as far as I can. You can also leave a comment in the section below, and I will respond as fast as possible. And in the next video, we will get the camera to follow along with our player.
And that's all for this video. So be sure to subscribe to my channel and click that bell button to get notified every time I upload a new video and to stay up to date with this series. And also, if you're a fan of this page, you can support me over at Patreon. Just go to patreon.com/mjdev. So thanks for watching, and I'll see you guys in the next video.